Okay, welcome back to the 4-7, the second part. I actually am including the example 2 on this video, even though it's under goal 1. But we'll do example 2 first, and then we'll move on to goal 2 of this part of this section. Okay, example 2 says, write an equation given a graph. Okay, so if they give you a graph, you should look for a point on the graph, and you should also look for the vertex. Now the vertex we know is HK. The point on the graph, any point on the graph is XY. Now, for me to write an equation of this graph in vertex form, I need to know y equals ax minus h squared plus k. Okay, so I'll need to know a, I will need to know h, and I will need to know k. In this particular problem, we are given hk. Here's h, and here's k. So h is equal to -1, k is equal to -2, and we don't know what a is. However, we do know that x is -4 and y is 13. Now that helps us because there are 5 variables here. We know 4 of them. All we have to do is plug those 4 in to find a, because that's the only one we don't know. So that's what we're going to do. We're going to plug in 13 equals a times x, which is -4, minus a -1 squared plus -2 or -2. Now, since we know all 4 variables besides a, we can solve for a. 13 equals a times, this is -3 squared, which is +9 minus 2, so I'm going to add 2. I get 15 equals 9a, so a is equal to 15/9 or 5/3. So now to rewrite the equation in vertex form of this graph, all we have to do now is put in the a and also put back in x and y. So my answer is y equals 5/3 times x plus 1, because x minus the -1 is plus 1, squared minus 2. There is the equation of this graph. Okay, the second goal of this section is to talk about transformations. Now I mentioned it earlier with goal 1, but section 2-7 was on the same thing. If you look back in your book at section 2-7, you'll find the list of values, what a is, and what transformations it does to the graph. Remember vertical stretch when a is greater than 1. If a is a fraction less than 1, it's a vertical compression. If a is negative, it's a reflection in the x-axis. As x is greater than 0, the graph shifts to the right. I should say h. As h is greater than 0, the graph shifts to the right. As h is less than 0, it shifts left. K shifts it up if it's positive, down if k is negative. However, we need to be able to identify this. So let's go ahead and identify what we know on this particular problem. Okay, so here's what we're looking at. We know that a is 1 because there's nothing there, so it's 1. H is 3, and k is -2. All right, so what that does for us is it on a table, if we were to actually make a table, x and y table on this, we know the vertex is hk, so it's 3, -2. Now, if you recall on our parent function, our parent function would look like this. It's 0, 0 in the middle, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. And of course the graph 0, 0, 1, 1, 2, 4. Now, on a normal graph, when A is 1, we always went over 1, up 1, over 2, up 4. So in this case, if I add 1, I add 1 here. So 4, negative 1. If I add 2, I add 4 here. So that's 5, 2. Okay, so if I graph that, I've got 3, negative 2. If I go over 1, I go up 1. If I go over 1 this way, I go up 1. If I go over 2, I go up 4. Over 2, up 4 here. And there's my graph. So that was using transformations. The transformations, of course, if you have to list them, you're going to the right 3, down 2. Now, let's look at this next one. This next one has an A value that's not 1. It's 0.25. H is negative 1, but K is 0 because we're adding a 0 on the back side here. So my vertex is negative 1, 0. Which is right here. Oh, that's negative 1, negative 1. Negative 1, 0 is right here. Now, rather than going over 1, up 1, like on our parent function, we would go over 1, up A. You're always taking the parent function y values and multiplying it by A. So instead of going over 1, up 1, we're going to go over 1, up 0.25. And of course, mirror on the other side. Okay, so on our table, instead of negative 1, 0, we're going over 1. We're going to multiply this one times A. 0.25. Over 2, instead of going up 4, we take 4 times 0.25, which is 1. So up 2, which is plus 1, over 1, up 1, so that's our next one. Over 1, or excuse me, over 2, up 1, over 2, up 1 here. It's a very flat graph because the A value is less than 1, and therefore it's a vertical compression. Okay, so hopefully you remember what we talked about back in section 2.7, that, you know, with the parent function and the standard, what happens. Remember, if A is anything other than 1, you multiply the y value of your typical parent function by that to get the y value of the new one. And that's it for section 4.7. Hopefully that goes well for you. Let me know if you need some help.